How we doing, guys? We're on text and test 4, page 332, 333. Still looking at arithmetic sequences, and this time it's arithmetic sequences, which anyone has this pattern here. Something times the number of the term plus c. Okay, so first term n will be 1, second term n will be 2, third term n will be 3. And you can see here, you're going up in question 1, part 2, you're going up in 20s, so d would be 20 here. C is some number that has to be added or subtracted to 20 times 1, 20 times 2, 20 times 3 in this case. And you can always find it by, again, just to come here, if you look at that, you're going up in 20s. If you work backwards, you're going down in 20s. Keep subtracting 20. What we might call, if that's the third, second, first term, the 0th term, which I never actually write on the same line as the actual sequence. Sorry, if you take 20 away, the 0th term will be -4. And that is your C, as it turns out. C will always turn out to be the 0th term. Now, by the way, if you go looking back in the book and looking at their methods and their examples, you'll see a different set of examples and methods, and even a slightly different formula. I use this one. If you like the other one, fine, you can talk to me about it in class, but I'll be using this one. So for the question 1 part 2 asks you for 16, 36, 46, 56, 76, find the nth term in the sequence. So the answer is, the nth term is, you're going up in 20s, so d is 20, that's called the common difference. And then your 0th term here, so 20n minus 4. And you can check there, the 4th term is 20 times 4, 80, take away 4, 76. That's the 4th term. Question 3, part 1, says find the number of terms in each of the following arithmetic sequences. And I should have had a 75 in there. So if you look at it here, this one is going up in 4s, plus 4, plus 4, plus 4. Okay, and if you were to work backwards and subtract 4 from that last term, your 0th term will be -9. So this is Tn equals 4n take away 9. And just check it there. Your third term is 4 times 3 is 12, take away 9. Yeah, there you go. And we want to know if 75 is the last number in the sequence, how many terms are there in the sequence? Well, that's basically saying, where does 75 land? What is the n value for 75? So that's n is 1, n is 2, n is 3, n is 4, and up here we're saying, well, what's n? So to do that, you'll just say 4n minus 9 is 75 and solve that equation for n. So you say 4n, 75 plus 9, 4n is 84, then n is 84 divided by 4, which is 21. Okay, so there are 21 terms in the sequence. Moving on, question 4 tells you the first term in an arithmetic sequence is 4 and the 7th term is 22. Now they ask you to find the values of a and d, which is using their notation. I'm just going to say find Tn. So Tn equals what? Okay, so what we're going to have to do for that is find d and c for our purposes. Well, we know that the first term is 4, so we can say d times 1 plus c equals 4. Okay, remember, for an arithmetic sequence, it's always going to be dn plus c. So that says d plus c is 4. And this one says d multiplied by 7, d times 7 plus c, or the 7th term, is 22. So 7d plus c is 22. Two equations and two unknowns. This is simultaneous equations. Line them up. 7d plus c is 22. d plus c is 4. Subtract them, you get 6d plus 0 equals 18. So d is 18 divided by 6 is 3. Okay, and then d plus c is 4. 3 plus c is 4. C is 1. Okay, and now that's not quite what you were asked for. The nth term is what I said. Sorry, I'm going to keep working over here. Tn is, well, d is 3, so it's 3n and c is 1 plus 1. Just check. The first term then is going to be 4. 3 times 1 plus 1 is 4. And the seventh term, 3 times 7 is 21 plus 1 is 22. So you know you have it there. Second part of the question says the first 5 terms in the sequence. Well, that's going to be T1 is 3 times 1 plus 1 is 4. We've had that already. T2 is going to be 3 times 2 plus 6 plus 1 is 7. T3 is 3 times 3 is 9 plus 1 is 10. T4 is 3 times 4 is 12 plus 1 is 13. And T5 is 3 times 5, 15 plus 1 is 16. And you can see here you're going up in threes, that's why you have the 3. And if you work backwards, 16, 13, 10, 7, 4, your 0th term would be that plus 1. Just to point out, there's a reason this might feel familiar for you. You've seen essentially this formula before when we did coordinate geometry, y equals mx plus c. In fact, if you plot these patterns out on a coordinate diagram, you'll get a straight line, okay? And that's the equation for a straight line in coordinate geometry. You can see y is your term in this, 4 or 22 or what the number is in the nth place. N is what your x value would be. Your slope and the common difference, the amount you're going up by with each step. So in this case, the 3 that you go up by with each step is d, and then c, your y-intercept and your 0th term are the same idea as well. I'm going to finish off with 7 part 1. If 2k plus 2, 5k minus 3, and 6k are 3 consecutive terms in an arithmetic sequence, find the value of k if k is an integer. If they're consecutive, that means if you subtract the highest from the second highest from the highest, you're going to get the same difference as if you subtract the first from the second. Okay, so the third minus the second should be the same as the second minus the first. So we should find that 6k minus 5k take 3 is the same as 5k take 3 minus 2k plus 2. And just to show you what I've done there, if we come back to this pattern from question 4, which was 4, 7, 10, 4, 7, 10, 13, 16. If I pick any 3 terms that are one after the other, 3 consecutive terms here, you can see that 13 take away 10 is the same as 10 take away 7. You get 3 in both cases, which is the common difference, the 3 that we had here. So that's what I said here. I've said this term, take away the term before it, is the same as this term, take away the term before it. And solving that for k will get us our answer. So that's going to be 6k take away 5k is 1k. Take away negative 3 is the same as plus 3. Is the same as 5k take away 2k is 3k. Negative 3 take away 2 is negative 5. I'm moving things around there. Let's move this over and make it plus 5. Move this over and make it minus k. We get 3 plus 5 is 3k minus k, which is the same as saying 8 equals 2k, and k has a value of 4. I'm going to ask you now to do questions 1, 2, 3 in their entirety, and question 7 part 2, which is very similar to this one here. In class, we're going to finish this exercise. Okay, thank you.